Okay, let's talk about logarithm functions. You're really probably not going to understand this definition, but it is the definition of a logarithm, so let's get started there. B and n are positive numbers. B is not equal to 1. Then the log of base b of n is equal to k, if and only if b raised to the k is equal to n. Let's see if we can't decipher this. B is considered the base. B, base. So I've put b in here of some number. So log base b of n. And k is your exponent. Remember, I'm always going to tell you, just please remember this, a logarithm of a number is an exponent. So all you're looking for is the exponent of something. So here's two forms of the numbers we're going to be converting in this section. This on the left side is considered exponential form. On the right side is logarithmic form. So you're going to be converting from one to the other and back and forth in the first section of the book. So as you can see, 2 raised to the third power is equal to 8. Nothing new there. 2 is the base, 3 is the exponent, and 8 is the result when you raise 2 to the third power. In logarithmic form, though, the base is 2, so we put the 2 down here as a little subscript after the word log. And the answer of what you obtain when you raise 2 to a certain power goes here, because you're taking the log of this number and saying 2 raised to what power is equal to 8. Well, 2 raised to the third power is equal to 8. Now I know right now you're not going to think, what am I going to use these things for? But you'll find out later on. You just have to be able to convert these things from exponential form to logarithmic form, and logarithmic form back to exponential form. So 2 raised to the fourth power is 16. That means that the log, base 2, of 16 is 4. 3 raised to the third power is 27. Nothing new there, but the log base 3 of 27 is equal to 3. 3 raised to the third is equal to 27. You really got to get this notation down. Anything raised to the 0 is equal to 1. So the log base 4 of 1 is equal to 0. So the log of any base of 1 is equal to 0. 5 to the minus 1, remember what we do with negative exponents, it puts it on the denominator as a 5 to the first power, so we have 1 over 5, so that the log of base 5 of 1/5 is negative 1. So don't forget now, a logarithm of a number is an exponent. Now we're going to do some problems. Here's the first one. Page 470. We're going to do 1, 8, 11, 14, and 23. All the ones before your assignment, so you have an example of every one of them. Number 1, log base 4 of 16. This is how you convert them. 4 raised to some power, which you don't know yet. So you're going to say 4, you're going to convert this to 4 to the x, put your exponent in the, make your variable the exponent, that's what I'm trying to say, is equal to 16, this number. And then you're going to solve it. Now how you solve these is you need to get, remember, like bases raised to powers, and then we can set the two powers alike like I showed you in class. 4 squared, we know this one, is equal to 16. So we know that 2 is equal to x. That means that log base 4 of 16 is equal to 2. This one was pretty easy and pretty simple, but as we get going, they become a little less simple. Now log base 2 of 1/8. It says 2 raised to what power is equal to 1/8. So we write 2 to the x is equal to 1 over 8. Well, you also know that if I put some number to the negative power, it puts it on the denominator, and the 8 is on the denominator with a 1 on the numerator, so 8 down here is really 2 cubed down here. So that means it's 2 to the minus 3 is equal to 1/8. So log base 2 of 1/8 is equal to negative 3, because negative 3 is the exponent. Again, log of a number is an exponent. Now we go on to this problem. The log base 4 of root 2 says 4 raised to what power is equal to root 2. Well, here's the one where you're going to take, this is 2 to the 1/2. That's what root 2 is. So we have 2 to the 1/2, and we change the 4 to be 2 squared, right here, to the x. Well, now I have 2 to the 2x is equal to 2 to the 1/2, so 2x must be equal to 1/2 for that to be true. Therefore, x is equal to 1/4. Then 4 to the 1/4 is equal to root 2. You just go right back here to the beginning. If x is equal to 1/4, 4 to the 1/4 equals 2. So then you can say that the log base 4 of root 2 is equal to 1/4. Number 14, the log base 3 of the 5th root of 9. You're saying 3 raised to what power, and that's where we put the variable, is equal to the 5th root of 9. So let's take the 5th root of 9 and let's see what it really is. It's 9 to the 1/5, isn't it? So we write it in exponential form. So that's your first step. Write everything in exponential form. And then you can put them in like bases. So 3 and 9 are kind of nice because 9 is just 3 squared. So instead of 9, we're going to take 9 right here and substitute in this equation 3 squared for 9. Once we do that, we have 3 squared to the 1/5. Now remember, when you have your exponent right next to the parenthesis, you just multiply these two exponents. 2 times 1/5 gives us 3 to the 2/5. Well, if 3 to the x is equal to 3 to the 2/5, that means x must be equal to 2/5. So we write x equals 2/5. So then you know that 3 raised to the 2/5 is equal to the 5th root of 9. In logarithmic form, we write log base 3 of 5th root of 9 is equal to 2/5.